awoke on not May 18th, but instead March 20th was the first day that we saw any activity. The first thing that happened with this eruption is something very interesting that we call harmonic tremors. And basically that means there was a series of earthquakes, and it was like boom, 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 one earthquake after the other, so fast that the scientists that were watching the mountain couldn't tell what was the start of one earthquake and the end of the other. They were so close together, they couldn't even tell. Now, of course, the mountain looked a little bit different. This is what it looked like on May 17th, 1980. This is taken from Johnston Ridge. It's a beautiful mountain. Now, looking at this beautiful mountain, what do you think people were doing around Mount St. Helens before it started erupting? Camping and hiking. They were enjoying the beauty of this nature. They were enjoying Mount St. Helens. Little did they know that Mount St. Helens was actually a volcano at the time. Now, of course, when it started having earthquakes and they started looking at it a little bit differently, they were able to see some features on Mount St. Helens. Now, this particular picture actually shows you one of the big aspects of the mountain that changed during the 1980 eruption. From March 20th through all the way to May 17th, there was a big old bulge that formed. And basically what that meant is pressure was building under the volcano, pushing up, pushing up, pushing up constantly. And the side of the mountain was pushing out, kind of like a big pimple. As gross as that sounds, that's the best comparison I can make. Under the surface of the mountain, there was this big pimple forming, and it was filling and filling and filling and getting bigger and bigger and bigger. And on May 18th, the series of events that was so destructive was in part due to this large bulge. Now, the first thing that happened on May 18th was a massive earthquake hit, a 5.1 on the Richter scale. Now, 5.1 may not seem like it's very big, but that's essentially enough to knock down probably a house, at least one that's not really that well made. So it would knock things off your shelves in your homes. And what it did is it hit this bulge, and it was so big that it literally fell off the mountain. And we saw a huge landslide. This landslide carried 2/3 of a cubic mile of material. Our trail is 2/3 of a mile. So if you were to take the amount of area inside of our trail, that would be the amount of mountain that was moved within just seconds. Seconds of this eruption. Now, of course, it started a chain of events that would change history forever. You guys saw the eruption cloud issuing out of the top of the mountain, yes?
Yeah.
It went 15 miles into the atmosphere. Now, planes, they only fly at 1 mile in the atmosphere. That is huge. So it flew up. Now, the same pressure that was released out of the top was also released out of the north face of the mountain. And it flew, again, 15 miles. 15 miles out. They had only evacuated out 5. That distance was huge. After all the ash cleared, they were able to see some of the devastation. We saw a 1-mile crater. Huge. Blasted out. The top third of the mountain was just missing. It had all been relocated into the valley. And when I say relocated, that landslide carried chunks of rock, like this one, off. Hundreds of miles an hour it moved. 120 miles an hour was the peak. And the temperatures in the ash cloud were about 600 degrees Fahrenheit. Okay? So it was a huge deal. Now, of course, as you look at this landscape versus, go back to picture 1, this landscape, this is before and after. This is in the same spot as this was taken.